Hi everyone, this mini lecture is on neutralization reactions. Okay, we already have a bit of an idea of what's going on with these acids and bases now. According to the Lowry-Bernstein definition, acids are things that donate protons and bases are things that accept protons. So many bases are actually OH minus hydroxide ion. And if you think about it, if you take a hydrogen ion and you add it to a hydroxide ion, you end up with this thing. And yep, it's water. So what this means is that for some acids and bases, when you add them together, if you've got equal numbers of protons and hydroxide ions, they simply cancel each other out, form water, and then the solution is said to be neutralized. So we can, if you like, express that with an equation. Here we've got H plus ions, OH minus ions with AQs after them, saying that they're aqueous. And as I pointed out, that whole idea is called neutralization. There's a YouTube video there for you to watch if you wish. Alright, what are some examples of neutralization reactions? Well, here's two here. We've got our old friend hydrochloric acid. It's reacting with a base. Now, nothing gets around in nature as just negative or positive ions. There's always another ion of opposite charge that hangs around with it. That's called a counter ion. And so, in this case here, when I'm looking at this base, what I'm seeing is, of course, it's Na plus and OH minus, and that's sodium hydroxide, as I said before in one of the other mini lectures. It's the stuff that you find in caustic soda or drain cleaner. So when you add these two guys together here, you can see what's going to happen now. This H plus and this OH minus get together and form water. There it is. So there's H plus, OH minus forming water, and of course what you're ending up with are these two ions here. This is actually Na plus, of course, even though it's never written that way, and this one in this formula I mean, and this one here, which is chloride ion. So we end up with this stuff, sodium chloride, which you well know is just common table salt. And of course, again, this goes back to earlier lectures. When you're looking at something like this, you know you've got a metal and a non-metal, therefore it's an ionic compound or a salt. The bottom line with this, of course, is that if you've got equal amounts, as I said, of hydrogen ions and hydroxide ions, they cancel each other out. It's neutral, and you just end up with salty water, basically. Here's one more example. We've got hydrogen bromide here, again an acid. And we've got potassium hydroxide this time, so it's the potassium salt of hydroxide ion. Same thing, that the hydrogen ion and the hydroxide ion react together and form water. And of course what's left over are these two compounds here. We've got positively charged potassium ions and negatively charged bromide ions, and we've got then this compound, potassium bromide, which is actually soluble in water, so it's again a salt that's dissolved in water. So I hope you can see there that there's a golden rule that kind of develops from all of this. As long as you've got a base that consists of hydroxide ion, if you add any acid to any base, as long as it's got hydroxide ion in it, you always get a salt plus water. And that's what I've got down here. Remember the golden rule. An acid plus a base gives a salt plus water, but of course only when that base is hydroxide ion. Okay, that's it for this mini lecture. Oh, sorry, beg your pardon. I just wanted to give you an example of a neutralization reaction. Here's one here. So in this case we've got sulfuric acid. So it's an acid, of course. We've got a base. Again, it's got hydroxide ion. The H plus ions will end up producing water here. And of course The other thing that we get is a salt, and in this case it's a fairly complicated salt. It's sodium sulfate, Na2SO4, and there's our salt there. And that's just showing you there what the thing looks like when it's balanced, and of course you can look at the PowerPoint as well if you wish, and of course the podcast. Okay, I'll leave it there, and I'll see you in the next mini lecture.